Good morning, Algebra I Honors. Let us begin. En nombre del Padre, del Hijo, del Espíritu Santo. Amén. Dios te salve María, llena eres de gracia, el Señor es contigo. Bendita tú eres entre todas las mujeres, y bendito es el fruto de tu vientre Jesús. Santa María, Madre de Dios, ruega por nosotros pecadores, ahora y en la hora de nuestra muerte. Amén. Del Padre, del Hijo, del Espíritu Santo. Amén. This week's lesson is going to encompass quadratics. All right? Now, we've done quadratics already, two types of them, for the property of zero and the square root property. So I want to review those two to make sure that you understand what they are. All right? So, the first example I'm going to give you is a very basic one, or let's say we have a problem such as m squared is equal to 49. All right? In this case, two things could be done. We could either move this over and go m squared minus 49 is equal to 0, then factor it out, and then set each factor equal to 0. M plus 7 equals 0, m minus 7 equals 0, where m has a solution set of 7 and negative 7. All right? That's one way. Another way is the square root property on this, which makes it a little bit easier. So we'll take the square root of each side. Now you got to be very careful. This side, the square root of m squared, you already know, is m. But when we take the square root of a number, in this case, because it's associated with an equation, you know that you're going to get a plus or minus 7 on that. That's the one you have to remember. A lot of these problems that you're going to be dealing with this week are going to have radicals in their answers also. You've already dealt with radicals. That's why I did that lesson last week. And now you're going to have some radicals in your answers here. All right, so let's look at another type of a problem that's similar to this. All right? So we have one like this. Now on this one, you have a choice. You can move the 45 over, factor out a 5, and then go from there. Or we can take care of this right now. We can divide both sides by 5. Simplify our problem. We're going to get a squared equals 9. Perfect. Take the square root of both sides. A is equal to plus or minus 3. You can see that's not very difficult. So you can simplify by dividing if this term is divisible by that coefficient. All right? So let's look at another one. I'm going fast on these because you've done these before. So let's say we have a plus 6 quantity squared is equal to 64. Now there are two ways of doing this. Multiply it out. FOIL. Move the 64 over. Factor. Set each factor equals 0. A lot of work. Why don't we take the square root of both sides? Now be careful with this side. Remember, taking the square root of something that's squared, these are opposites, so they kind of cancel. Not kind of, they do cancel. Therefore, you're left with a plus 6 is equal to, this is where some of you will make an error. Remember, that's going to be plus or minus 8. Now, we're going to solve. We're not finished yet. So we're going to move this over by subtracting 6. So a is going to equal negative 6 plus or minus 8. Be very careful of this because there are two solutions to this. Solution number 1 is going to be a can equal negative 6 plus 8, and a can equal negative 6 minus 8. So therefore, a in this case would equal 2. In this case, a would equal 14. Negative 14, excuse me. All right? So therefore, a has a solution set of negative 14 and 2. Notice how I'm putting all our answers in a solution set. This is telling me that these two solutions will work in here. All right? So notice what I did. Be very careful. And on something like this, you're going to get two answers. If there's a number with a plus or minus and another number, you're going to get two answers, not just one, two. So make sure that you separate and give me the two answers, all right? Okay. Let's go to the next one. Let's see. There's another example. I think most of them those are covered. But, all right. So let's look at this one. Something like that. That's kind of combining two things we just did. So in this case, let's take care of that 5. So let's divide both sides by 5. That's going to simplify to give us a minus 4 quantity squared is equal to 8. All right? Now we're going to take the square root of both sides. This side becomes a minus 4 is equal to, be careful on this one. Now this one, you can go ahead and leave it as plus or minus the square root of 8. We're going to deal with it in just a few minutes. All right? Move this over to solve. So a is equal to, add 4, plus or minus the square root of 8. We can't leave the square root of 8 that way. A lot of you are making that mistake on some of your homework. So we're going to rewrite this as a is equal to 4 plus or minus the square root of 4 and 2, which now becomes a is equal to 4 plus or minus 2 radical 2. Now we could have done this up here. We could have simplified it before, and that's fine if you do want to simplify it. But remember, now we can have radicals in our answer. You cannot combine these two because you did addition last week, and unless you have the same radicand here, can't combine. So this is your final answer right here. Make sure you see that. All right? One last problem on this, and we move on to the next concept. Let's see. How about this one? Y squared plus 6y plus 9 is equal to 49. Now, there's two ways of looking at this. Number one, we can move that 49 over. All right? So we can move that negative 49 over. All right? And then set it equal to 0 and then factor. All right? So if we do that, it'll be y squared plus 6y. And if I subtract 49, I'll get a negative 40 is equal to 0. Now we're going to factor. See what? All right? All right, so we have 10 and 4. Obviously, they're going to be. So we have y here, 10, 4, positive, negative. So this is going to be positive. This is going to be negative. We check. Yes. Set each factor equal to 0. Y plus 10 equals 0. Y minus 4 equals 0. So now I'll let you do this because some of you can already do it in your head. Y has a solution set of negative 10 and 4, as long as you set them equal to 0. But now, look at this problem here. I want to look at it again in a different way because we worked hard here. So let's look at you look at the problem. I'm going to leave the answers where they are, right here. You can see. Now, what if we factor this out? You can say, hey, we factor it out, we get y and 3 and plus quantity squared. Check it. Y squared, 9, multiply them, 3y, double them, 6y. You do get that trinomial. Now guess what? You can take the square root of both sides. So now you're going to get y plus 3 is equal to plus or minus 7. So y is equal to a negative 3 plus or minus 7. And now you know, negative 3 plus 7, positive 4, negative 3 minus 7, negative 10. Two ways of looking at it. So you've got to see, open your eyes. Can I factor that out? Is it a binomial square? It has to be a binomial square in order to work. If not, then you need to move that 49 over to combine it and then factor. But this makes it a perfect binomial square there. All right? All right. That'll suffice for the first section of that. Now, today, on the other section, we are going to begin the next type of quadratic, which is called completing the square. Now, this one is going to take steps, so you've got to follow. Look carefully, all right? So let me just give you an example of one problem that I'd like. Let me just grab one here. All right. How about this one? All right. In looking at this problem, complete the square. Step number one. All right. Step number one in completing the square. You always want, now normally this problem would be written, let me rewrite this so you can see it. Something like that, all right? Because that was -3, I brought it over. Now, step number one is move this constant, remember this is a quadratic linear constant. Move the constant number over. Move constant number over to the other side. You want it alone. So we're going to get a squared plus 6a is equal to -3. Okay? Second step. Take your linear term. You want to take half of this linear term. You want to say, take half of linear term. All right? So, in taking half, I'm going to take 6 divided by 2. That's taking half of it. What do I get? I get 3. Okay, hold on, we're not finished yet. Step 3. Take the result of step 2. The result is 3. And you're going to square it. So I have 3, and now I'm going to square 3. What do I get? 9. Now, so we took half of it. Take the 3, we're going to square it, we get 9. Now this answer for step 4 is going to be take the answer of step 3. Of step 3 and add to both sides. So I'm going to take that 9, I'm going to add it here. So watch what I'm going to do. A squared plus 6a plus 9 is equal to 9 minus 3. So again, let's go back. First, step 1, move this constant number over. Step 2, take half of the linear term. Half is divided by 2, you get 3. Take that result, square it, you get 9. Now take this result that you got from squaring it and add it to both sides. Here's what I did. I added 9 to both sides. Now, if you are correct with completing the square, you should always get a binomial square here. We just did the problem like this here. So we know that this is going to be a plus 3. You need a perfect square, or binomial square there, in order for it to work. Very good. Equals, in this case, 6. Hey, you already know how to solve these. Okay. Take the square root of both sides. A plus 3 is equal to plus or minus radical 6. Now we can't simplify radical 6, so therefore we move the 3 over. So a is equal to -3 plus or minus radical 6, and that is our answer. There's nothing else we can do with that. All right? So after you take, on step 4, after you take that, then on step 5, you're going to solve the quadratic. All right? So step 1, move the constant number over. Step 2, take half of the linear term. 3, take the result of step 2 and square it. All right? Now you take the answer to step 3 and add it to both sides and then solve the quadratic. I'm going to do another one. All right? I'm going to leave the steps up there so you can see them. All right. Let's try one that's not going to be quite as easy. I want to give you an example of one of these here. Okay, step 1, move that constant number over. So I'm going to move this over. I'm going to leave a little space. Equals 18. Notice I left the space there because I'm going to have to add a number. Now this is where this one becomes a little bit more crucial because this will not divide evenly by 3, so we're going to have to work with a fraction. But that's okay. So next, step 2, take half of the linear term. That's -3, and I take half of it. So it's -3 halves. I don't change it into a mixed number. Leave it like that. Now, I have to square it. Next step, it says square it. If I square both sides, I'm going to get 9 over 4. -3 squared is 9. 2 squared is 4. Now I'm going to add 9/4 to both sides. I should move this over. Okay? Now, you should get a perfect binomial square on this side. But you might say, Mr. R, how am I going to do that? How am I going to do that? I'm going to show you a trick. Watch carefully. In order to factor this out to get a binomial square, you know it's going to be x here. You know because it's negative, positive, it's going to be negative. All you have to do is go back up here. When you took half of the linear term, the 3/2 will be your term that you're going to use. I'll show you another one like that. And now we take 18 plus 9/4. Now you could also, one of two things. You could change this to 2, all right, and 1/4. Now if we add 18 and 2 1/4, we get 20 and 1/4. I don't like that. I want to change this into an improper fraction, and you'll see why in a few seconds. X minus 3/2 quantity squared is equal to, that's going to be 81/4. You see why? These two are now perfect squares. So there, I take the square root of both sides. I'm going to get x minus 3/2 is equal to plus or minus 9/2. You know you're on the right road when these two have the same denominator. I'm going to move over here. So x is equal to, I'm going to add, so it's going to be 3/2 plus or minus 9/2. So x is going to have the solution set of, what's 3/2 plus 9/2? It's going to be 12/2. So the first one will be 12/2, or 6. 3/2 minus 9/2. That's going to be -6/2, or -3. All right? So let's review. What did we do? We moved the constant number over. We took half of the linear term. Now this one, because it is not an even number, take half of it, I have to work with a fraction. Square it, I get 9/4. Add 9/4 to both sides. This is a perfect square. If you want, in order for it to work, it has to be a perfect binomial square. How do I get -3/2? Go back to where you took half of the linear term. That is always going to be your factor here. Always. And now I added 18 plus 9/4, which is, the 9/4 is 2 1/4. Add them, I get 20 1/4. I don't want to leave it like that. Let me change it to an improper fraction, because now you see that when I do that, I get 81/4, and they're both perfect squares, and they simplify, move it over, and remember, you're going to get two answers when you have a plus or minus. Okay? All right. Let's try another one. All right. Let's see. Now you already have a number over there. That's okay. I'm still going to move this constant number over. So I'm going to get c squared minus 7c. I'm going to add 2 equals 6. Half of the linear term. -7/2. That's half of it. Square it. 49/4. Add it to both sides. 49/4. This side should be a binomial square. Now remember what I said. You know it's going to be c minus. You go back up where you took half of this, and it's going to be -7/2. That's going to be your factor. If you want to multiply it out, go ahead. You will get that. Equals. Now, this one. All right? So be careful here. So if you want to change this to a mixed fraction, then you're going to get 1, which is 0, and then you go 2, 12, 48, and 1/4. So now if I add them, I'm going to get 18 and 1/4. Now, I don't quite want that. So I rewrite that as c minus 7/2 quantity squared is equal to 18 times 4. All right? So 18 times 4, 32 is 3 is 72. All right? So I get 73/4. Okay? Now, we're going to take the square root of both sides. This one is not going to work out as easy as the other, but it's still. So take the square root, so I'm going to get c minus 7 over 2 is equal to plus or minus, now, 73, I don't think it has any perfect squares. So I'm going to leave it under the radical. But remember, this can be rewritten as radical 73 over radical 4. I can take the square root of 4, which gives me 2. Now, remember what I just told you. How do I know I'm on the right road? Because they have the same denominator. So I'm just going to move this answer over to c is equal to, this is negative 77 halves, so I'm going to add it. Positive 7 halves plus or minus radical 73 over 2. There's nothing else I can do with that. Now, you could write it as one fraction. Either way is correct. You could say 7 plus or minus radical 73 over 2. And that would be the correct answer. And this is your final answer. So see, you are getting radicals in your answers there, okay? All right. Good, good, good. Now, one last one that I want to do with you is, what if we have a problem like this, real quickly. 5x squared plus 8x plus 1 equals 0. If you've noticed, all the other problems, the quadratics that I've given you, the coefficient of the quadratic term has always been 1. It has to be 1 in order for it to function and in order for you to complete the square on that, okay? So what I'm going to do here is, in order to eliminate this, because I want it to be 1, I'm going to divide everything by 5. So now I'm going to get x squared plus 8 over 5x plus 1/5 is equal to 0. This is more complex. Same thing. Step 1, move that constant number over. X squared plus 8 over 5x is equal to a negative 1/5. Take the linear term, 8/5. Now this is where I want to do this. Take half of it. If you divide it by 2, it's the same as multiplying by 1/2. Divide by 2, you multiply and get the reciprocal. So this becomes 8/10. Then I'm going to square it, and I get 64 over 100. So I'm going to add 64 over 100 to both sides. All right? This one right here should be a binomial squared. So we should have x, it's going to be plus because they're both plus. Go back. When you took half, what did you get? 8/10. All right? Is equal to, now, on this one, let's go ahead and find the common denominator, which is 100. So we go 100 divided by 5 is 20. 20 times negative 1 is negative 20 plus the 64. Same, 100 divided by 100 is 1 times 64. All right? And then now we're going to, difference here. All right? So we have 64 minus 20. That would be easy. All right? 44. All right? Be positive 44. So I have positive 44 over 100. All right, same thing now. We're going to take the square root of both sides. So now we're going to have here x plus 8/10 is equal to a plus or minus. Now, I'm just going to rewrite it, both of them. Radical 44 over radical 100. Now, we may want to simplify this. And some of you may say, Mr. Art, can I simplify this fraction? You could. You could simplify it to make your math a little bit easier, all right? But now, let's just work with it like that, all right? So here, I need to simplify this because I know this has radical 4 and radical 11. And then this is just the square root of 100. Square root of 100 is 10. So my final one is going to be x. This is not my final answer. I'm just simplifying it. 8/10 is equal to plus or minus 2 radical 11 over 10. You know I'm on the right road when I have the same denominator. That's why I didn't simplify it. So you can see that I have that same denominator. I'm going to move up over here. So now we're going to move this over. So it becomes x is equal to a negative 8/10 plus or minus 2 radical 11 over 10. We can't add them. We can't do that. We could write it as 1 if you want. We could do x is equal to negative 8 plus or minus 2 radical 11 over 10. Now, at this point, if you could simplify and get the same answer in your denominator, you would do it. But right now, I'll tell you just leave it that way. So what did I do? In order to complete the square, I have to make sure that my coefficient of my quadratic term is 1. So I divide everything by 5. That means I'm going to end up with fractions. But look how easy it works out to when you have something like that. All right? On that answer. All right? So what do? We took 8/5, the linear, took half of it. Remember, half of it means multiplying by 1/2. Got the answer, square it, add that to both sides, simplify. Remember, we get the 8/10 after we divide it by 2. And here, what do? We found the common denominator and got 44 over 100, took the square root, simplified it in there. And you can simplify this but I'm going to leave it like that for right now because I don't have the opportunity to show you how to simplify it to make sure. All right? All right, the last one we're going to be working with here on quadratics is the quadratic formula. All right? The quadratic formula. If we were in class, I'd show you where it comes from, but the quadratic formula is very simple. It says x is equal to negative b plus or minus the square root of b squared minus 4ac, all of this over 2a. A lot of letters. But let me show you something. When we have a quadratic problem, all right? For example, if I give you a problem like this, 3x squared plus 5x minus 2 equals 0, and I want to use the quadratic formula, you have to remember that the standard way that a quadratic formula is written is ax squared plus bx plus c equals 0. That's where the a, the b, and the c comes in. Notice that your a is going to be 3, your b is going to be 5, your c is going to be negative 2. So all we need to do is substitute. So we have x is equal to negative, what is b? B happens to be 5, plus or minus the square root of b. It's 5 squared, minus 4 times a, 3, c, negative 2, over 2a, which is 3. All it is a substitution. So x is equal to negative 5 plus or minus the square root of 25. Now negative and negative is going to be a positive. That's going to be 12. 12 times 2 is 24. All right? Over 6. Simplify. So we have x is equal to negative 5 plus or minus the square root of, let's add those two, what do we get? 49. Isn't that beautiful? Over 6. So we're going to simplify 49. So x is equal to negative 5 plus or minus 7 over 6. Now we have to simplify that like we did the others. Remember, we have plus or minus, no variables. So we're going to get two problems here. X is equal to negative 5 plus 7 over 6. And x is equal to negative 5 minus 7 over 6. All right, the plus 7 over 6 and the minus 7. So x in this case is going to equal, this is going to be 2 sixths or 1/3. This is going to be x is equal to, this case, 12, negative 12 sixths or negative 2. So I'm going to have an answer of x is equal to negative 2 and 1/3. All right? All it is a substitution process. You don't have to, but you need to remember, put it in standard form, all right? Which is quadratic, linear, constant. Some of these problems, we're going to switch things around. Make sure everything has to be in this form, ax squared plus bx plus c. If the 2 was over here, you'd move it over. If the 3x was over here, you move it over. All right? And if it's negative, and you just carry it through. Be very careful when you're working with your signs on this. This is just a substitution on the quadratic formula. All right? I'll do one more, and then that'll be about it, guys, for that. All right, last one here. I'm going to erase the 2A. Let's just grab one here. What if we had a problem like this? All right, something like that. So you ask yourself, is this in descending order? No. So let's put it in descending order. 8m squared minus m minus 5 equals 0. Let's start the process. X is equal to negative b. Now b happens to be negative 1. So again, that negative is part of the problem, and b happens to be negative 1. So you got to put the negative 1 in there. That's where some of you would think, oh, the negative, I just put the 1. No, it's negative 1. Plus or minus the square root of b, which happens to be negative 1, quantity squared, all right, minus 4. A happens to be 8. All right, c happens to be negative 5. All right, all of this is over 2, and a is 8. All right, so you have your b, right? You have your a here, you have your b here, and you have your c here. Remember that this is a negative 1. All right, so we have x is equal to 1 plus or minus the square root of, let's see, we get 1. Negative, negative is a positive. All right, I have 20 plus 8, times 8. 20 plus 8 is 160. All right, over 16. All right, so now we move this over and we can get x is equal to 1 plus or minus the square root of 161 over 16. All right, now if we can simplify 161, then we would do it. If we can't simplify it, then we leave it the way it is, and this would be your answer. There is no way that we can get two answers. The only way you can get two answers, like the other problem, is when you have a regular number here. But we do not have a regular number, we have a radical. So we're going to have to leave it the way it is, and that would be your answer on that. Okay? All right, 8th grade. This will be the last lesson that I'm doing with you in quadratics. I wish I could have gone a little bit further with you. It's been a pleasure. You have been superb students. I'm hoping and praying that we will be able to get together one more time after graduation in the summer, maybe. Just one last time to say goodbye to each and every one of you. You have been superb for 3 years, especially the last 2 years when I've had you as my honor students. Be safe, be good, God bless you.